For our uniform velocity spreadsheet, we need these headings. I'm going to now do the formulae, but just before I do that, I'm going to insert a time increment. I'm going to pick 1/4 of a second. Notice that this heading here has been right justified, so normally it would look like that, left justified, but I've put it in as right justified, same as this one. Initial displacement, I'm going to say 0 and meters. Notice that these two numbers here must be the only thing in the cell. You can't have any letters in that cell, no letters in that cell for the formulas to work further down. Let's begin time at 0, and then this cell here, we're going to put in a formula. We're going to say that this time in this cell is equal to the cell before plus this time increment up here. Enter. And I could keep going like that. I'd like to be able to fill down and have things come right, but that's not working because here it says A12, which is 0.25, plus C5. It's looking for something in this cell. There's nothing there. So that's no good. I have to go back here and put in $4 so that this formula knows to always go to that row 4 and not go looking underneath it. Now I can fill down, and we'll go down. I'm going to stop at 5 seconds. The other thing I like to see when we do spreadsheets is that we indicate which cells may be altered when we start manipulating numbers. So let's colour those two cells and say those two can be changed. Velocity, now here this is the one that we're going to alter at will, so I'm just going to put some number in there and fill that down. So that's where we get our uniform velocity, same velocity all the way, and that's one that we'll come back and we'll change to see what happens. Let's go back. Here's something I missed. I like to get these columns nice and tidy. Tidy up the numbers so that they have the same number of decimal places, and centralize the numbers. This one here, we could make that in the center as well. Incremental displacement, well, up until time 0 there's been no increment, so we come down to this one. Here we're going to write down how far the motion, how far we've gone in 1/4 of a second travelling at 3 meters per second. So we need a formula equal to, and let's just remember that using this statement about velocity, we rearrange it to make displacement the subject of the equation, and we get displacement is velocity multiplied by time. So here we're going to go velocity multiplied by time. It's this one here. It's always going to be 1/4 of a second. And once again, we have to put in the dollar so it keeps going back to that same row. So there's how far we went in that 1/4 of a second, and it's going to fill down, calculate each little time interval, each increment, and it'll give the same answer because we've got uniform velocity. When it comes to overall displacement, first of all, let's not do that. Let's say it's equal to initial displacement as our starting point, and then in that first increment, in this case 1/4 of a second, we have gone this far plus the change, the extra amount that have gone in that time increment. So it's that one. And enter. No need for dollar signs this time, it's going to fill down nicely and just accumulate as it goes. So by the time we end up at 5 seconds at 3 meters per second, we have gone 15 meters. Once again, let's tidy up the number of decimal places and centralize, and there's our columns filled in and our changeable cells being highlighted.